But you know what happens in the thermosphere?
Go ahead.
Not only does it absorb the high energy ultraviolet and the X-rays, that's where the buck stops with the solar wind.
Right.
And that's where aurora take place.
Ah, look at that.
In the thermosphere. Because the particles hit oxygen molecules, nitrogen molecules, bumps up the energy of the electron.
Okay.
Okay. So it took the energy, the electron is sitting at a higher energy level, and then unlike people, atoms don't like remaining excited. So they spontaneously de-excite and send visible light in these shimmering curtains into the atmosphere that we see aurora.
Aurora.
It's beautiful. One more layer. And
after the thermosphere.
I shouldn't even call it a layer.
Shouldn't even call it a layer. But there are some molecules up there.
It's the exosphere.
Okay. What's going on there?
Nothing. It's where the density of air from our atmosphere blends into the density of particles in interplanetary space. At which point you don't know which one you're...
I was going to say, how do you make that differentiation?
It's when the densities are about the same, and then you're done.
So right.
You're done with Earth's atmosphere at that point.
You have transitioned.
And where do we orbit our low Earth orbit objects? You know, the space station, the space shuttle. Well,
right.
Not the space shuttle anymore.
But
SpaceX,
right.
Crew Dragon, all of them. They all orbit sort of in the upper thermosphere. You may not know that we intermittently have to boost the space station. Why do we have to boost the orbit? Because especially the space station that's got all of these solar panels.
Because
there's still some air molecules there.
So you don't want all that slapping up against there.
Except it happens.
Right.
That decays the orbit.
Right.
So every time we send up another craft, if it's in the schedule, it'll use its engines to boost it because there's still air molecules there.
Gotcha.